Hey everybody, welcome back to chemistry. And so in the previous video, I talked about how to figure out the electron configuration of an atom. Now what I need to do is show you an abbreviated form or shorthand form for this electron configuration. So let me just give you a quick idea here what we're kind of looking into next. So let's say you're looking at the lithium atom. The symbol for lithium is Li. And there are 3 electrons there. And so I'm hoping at this point you can write a correct electron configuration for the neutral lithium atom. So we have 3 electrons, and so the first 2 electrons go into the 1s sublevel, and then the next electron goes into the 2s sublevel. Okay, so let's write this configuration in now the abbreviated way. And so this is how you do it. First, let's notice what's going on with this configuration. We have 2 electrons in the 1s sublevel, and we have 1 electron in the 2s sublevel. And so you might recall the element that has 2 electrons in the 1s sublevel. That element is a noble gas, which is helium. So another way we can write this out is we can say, well, let's write out lithium's configuration and just note here, it really is just helium's configuration followed by 1 electron in the 2s. And so here, whenever we have some kind of symbol for a noble gas followed by some sublevels, this is the abbreviated or shorthand electron configuration. So what we're going to do next is we're going to figure out what the configurations are for phosphorus using this abbreviated configuration. And then what we're going to do is iodine. However, you're going to see I'm going to need a periodic table for this. And so if I can blow up the slide. So the first thing I want to do is figure out where phosphorus is in the periodic table and figure out how many electrons it has. And so it looks like here is phosphorus and it has 15 electrons. And so what I want to do is write an abbreviated electron configuration for phosphorus. And so first thing I have to do is identify the noble gas that just precedes it in terms of electron number. So phosphorus has 15 electrons, and the noble gas that just precedes it has 10 electrons, and that is neon. We can sort of see now that phosphorus is going to have neon's configuration of 10 electrons, and then you're going to add in 5 more electrons for a total of 15 electrons. And so what we might expect is phosphorus with 15 electrons, its configuration is going to look like this. It's going to be neon. And then what we may have to do is we have to figure out the orbitals that the 5 extra electrons go into. So that's a little tricky, so I need to show you how to do that. So one thing you sort of have to be aware of is that you can divide the periodic table into sublevel blocks. And so let me identify 2 of the major ones here. So we have one here, all elements in blue are said to be in the S sublevel block, and that will also include helium here. And then the other one I kind of want to point out right now is here all elements in green are in the P sublevel block. So now let me talk about what that means. If you find an element in the S sublevel block, what that indicates is that the last electron you add to its configuration will go into a S sublevel. So let me give you a quick example of that. So let's take a look at hydrogen. And so you know hydrogen, its electron configuration is this. It has only 1 electron. So there it is, that's 1 electron of hydrogen there. So that is the last electron of hydrogen. So what sublevel is it going into? Well, you know that it's an S sublevel in the first energy level. So we would expect that hydrogen would be a part of the S sublevel block, and it is. Okay, let's say you had helium. Helium has 2 electrons, and you know its last electron also goes into an S sublevel. It happens to be in the first energy level, and so we would expect helium to be a part of the S sublevel block, and it is. Now, let's say we were going to look at lithium here. So here's lithium. It has 3 electrons, 2 are there. So the last electron goes to the next orbital out. So there it is. And so you might remember the next orbital that's filled is an S sublevel, but it happens to be in the second energy level. And so what you might expect for beryllium, beryllium is also going to be in the S sublevel block because its last electron is going into an S sublevel, which happens to be in the second energy level. But now let's think about boron. Is boron going to be in the s sublevel block? Well, here is boron's configuration. It has 5 electrons. There are 4 here. And so the 5th electron, you know, is actually going to be put into a p orbital in the p sublevel in the 2nd energy level. So the electron goes here. So with these elements here in green, what you would expect is that the last electron you place in its configuration will go into some kind of p sublevel. Now additionally, one other thing you have to sort of understand is what energy level that electron will be in. So let's consider the s sublevel block. So the energy level that that last electron will be in the s sublevel block is easy to figure out. It has the same value as the period of the element. So for example, hydrogen and helium are in the 1st period, therefore their last electrons will go into the 1st energy level. Lithium, beryllium are in period 2, and so the last electron added to its configuration will go into the 2nd energy level, and so on. And so for example, if you were down to cesium, what you would find is that it has 55 electrons, and what you would see is that that last 55th electron of cesium would be going into an s sublevel, but it's going to be in the 6th energy level. Okay, now how about elements in the p block? Same deal here. This row of elements are in period 2. And so therefore that last electron for these elements here will be going into a p orbital that's in the 2nd energy level, and so on. So for example, if you're like looking at, say, polonium here, its last electron will be going into a p sublevel because polonium is in the p block, and it's going to be into the 6th energy level. Okay. So at this point, let's go ahead and try again and see if we can figure out the electron configuration of phosphorus. Okay, so here we go. So let me erase some things here really quickly. Clean this up a little bit. Okay, so here is phosphorus. And it has 15 electrons. So we're going to write an abbreviated configuration. And so you can see that the noble gas just preceding it is going to be neon. And so next thing you have to do is figure out the next orbitals that the additional 5 electrons go into. So 2 of the 5 electrons you're going to add in will next go into the s sublevel in the 3rd energy level. We know that because we're passing through the s block. Now, once we're out of the s block, we go across the periodic table and we're now into the p block in the 3rd energy level, and we're going to add 3 electrons there. And so here the configuration is going to be 3p3. And so this is phosphorus's electron configuration. Also, there are some other sublevel blocks you need to be aware of. So these elements in red here are part of the d sublevel block, and so what you can imagine this means is that if you pick one of these elements here in the block, when you're writing out its configuration, its last electron will go into a d sublevel of some energy level. Now, if the element happens to be in the 1st row of the d sublevel block, something like iron or nickel, something like that, you need to know what energy level that electron is going into. And it turns out that here, this 1st row here of the d sublevel block, the energy level that the d sublevel is in is the 3rd energy level. Now, if you have an element in the 2nd row of the d sublevel, then the electron in the d sublevel will be in the 4th energy level, and so on. Also, just be aware that there is an F sublevel block here. Here is the F sublevel block. And you just have to remember that the elements in the 1st row of the F sublevel block, their last electron in their configuration will be going into an F sublevel. If the element is in the 1st row, it'll be an F sublevel in the 4th energy level. If it is an element in the 2nd row, it's going to be an F sublevel in the 5th energy level. Okay, so using that information, let's go ahead and figure out the configuration of the iodine atom. So we have iodine. It has 53 electrons. what is its electron configuration? We want to do an abbreviated one. So first, let's figure out where iodine is in the periodic table. It is here. And so we identified the noble gas that just precedes it. It is krypton with 36 electrons. So we write krypton like this, and we know that that has 36 electrons. And so we need to add more electrons to get up to a total of 53 electrons. And so we go from krypton, and you can see as we fill up to head over to iodine, the first thing we go through is the S sublevel block. So we can see that 2 electrons are going to be added to an S sublevel. The problem is, what energy level is it in? So 1, 2, 3, 4, 5. It looks like it's in the 5th energy level. So the next 2 electrons are in 5s2. And then to get closer to the iodine atom, we're going to have to go across the D block. And so you have to recall whether these D orbitals here that are being filled, is it in the 3rd, 4th, 5th energy level? What is it? Well, if the element was in the first row of the D block, it would be the 3rd energy level. Because we are going across the 2nd row here, it's going to be in the 4th energy level. So the 4D will be filled up with 10 electrons. And then finally, it looks like we need to add 5 electrons to the next orbitals. And so now we're in the P block. Let's see how far we are down here. 1, 2, 3, 4, 5. It looks like the P block that is being filled here is in the 5th energy level, so we write 5P5.